Most AVD admins don't think a whole lot about storage. You pick which disk you want for your hosts, you set up FSLogix, and you move on. But here's the problem. That set it and forget it mindset locks in waste. And it pretty much guarantees a rough conversation when management wants to know why AVD costs keep growing. So instead, let me show you 4 things AVD admins keep getting wrong. The first thing you keep getting wrong is thinking shutting a VM down stops your cost. Deallocating your 40 VMs at night or automating it with autoscale does stop the compute cost, but those 40 premium SSDs just keep on billing all night long. So go into Nerdio Manager and find your host pool, and now click the 3 dots, go to autoscale, and configure. Now if you haven't set any of this up yet, I'll link my autoscale video at the end here. For now, scroll down to this section where you'll find the stopped OS disk type. And in the drop-down, you can select a standard hard disk drive. Then click Save. Now this will dramatically reduce the cost of your storage, but here's a pro tip just because you're subscribed. If you're using Start VM on Connect with autoscale, just be aware that Start VM on Connect, which is a dedicated AVD control, doesn't know about the state of your disk. So if the VM were to start up, it would still have a hard drive, and that would hurt your performance. So you should instead use the pre-stage function, which will make sure that your hosts are set back to premium before your users start connecting. And while that's a great approach for hosts that you need to keep around all the time, but of course, the cheapest storage is storage that doesn't exist. And we can do that in 3 ways. Let's say you finished up that week of company training and it was late on a Friday and you're pretty tired. But the longer you wait to delete those 40 hosts, the more it costs. So you can easily go into Nerdio, go to your host pool, click the 3 dots, and just delete the whole thing. Or if you need that pool to stick around, you can just go to hosts and then delete all. Of course, you could also configure autoscale, which we covered in that video recently, and that gives you 5 different sections of ways to scale and almost 20 different controls overall. And there's no more robust scaling tool anywhere in VDI. The third thing you keep getting wrong is with FSLogix. And that's because cloud file shares are complicated. So let's break it down. There are 3 supported file shares: scale-out file servers, Azure NetApp files, and Azure files. Now, this one is used usually in Azure Local and upcoming AVD hybrid solutions. In the cloud, NetApp is the mega enterprise class offering with performance up to 400,000 IOPS. And you can just change the size of your volumes on demand, which really means you have to consistently manage it to control your costs. Then there's Azure files, which comes in 2 flavors, standard and premium. Standard are built on top of hard disk drives and gives you up to a certain number of performance, which means it's a lower cost solution and you're billed based on how much data you put into that share. So you can build a 100 terabyte share, fill it with 10 gigs, and you're only charged for 10 gigs. Premium, however, is built on much faster SSDs and gives you guaranteed performance. And your billing and your performance are based on the size of the share, no matter how much data you have. So a 100 terabyte share costs the same if you have 10 gigs in there or 100 terabytes. So the trick is to size it based on how much storage you need, like 30 gigabyte profile size times 300 users is 9 terabytes of storage. But that's only half the story. In Azure, if you go to your file storage and create a new share, just scroll down a little bit, and you see here the max and burst I/O rates. Now, on average, a user signing into FSLogix will use about 50 IOPS of storage performance, and then after their login is complete, they use roughly 10 IOPS. So if we calculate those 300 users at 50 IOPS apiece, that's 15,000 total IOPS if they all logged in at the same time. So set your storage to 9 terabytes, and see that only gives you 12,000 IOPS, but you would get 27,000 burst. However, burst doesn't mean extra performance whenever you want. Burst is more like a credit card, and baseline is your paycheck. So if you use less than your baseline, you build up credits, and you spend them during those logon storms. So burst won't help in this scenario. But if you increase the share to 12 terabytes, then you get the 15,000 IOPS that you actually need. Now, another pro tip that you need to know is that you can grow the share at any time and instantly get more performance. But you can only shrink to save cost once every 24 hours. Now, to change your share size, you just scroll down on the left and open your storage, go to Azure Files, click the 3 dots on your share, then go to Auto Scale and Configure. And we've got here 3 sections: quota, scheduled quota increase, and scaling logic. The quota unit can be relative, which is just a percentage of used capacity, and that will grow or shrink along with you, or an absolute size. Now, the minimum for premium is 100 gigs, and just keep in mind that your size can't be actually smaller than your used capacity. Then we've got the min and the max. So auto scale doesn't just grow forever. Now, if your environment has predictable spikes like the end of month operations or your daily logon storm, you should enable your scheduled quota. Select your days, hours, and then a time zone. And then you just select the quota that you need. That way, your users aren't waiting for performance when they actually need it. Finally, we have the scaling logic, starting with the trigger. And that sets your latency for max or average, then how much to increase the quota for scale out and scale in once your threshold is reached. Then just enable it and click Save. Now, the last thing you all keep getting wrong is believing that you need an OS disk at all. And not only do you not need disks, AVD will be a lot faster too. Now, the catch is that you have to treat those hosts like cattle and not pets. You just create them, use them, and destroy them. Go to your host pool, click the 3 dots, go to your hosts, and now resize and re-image. Ephemeral disk only works on Azure VM sizes that have at least the 128 gigabytes of local cache, like the D8 ADS V5. And you can see the entire list of Azure VM sizes that support ephemeral disk using this PowerShell, which is linked in the video description. Just select the VM size you want, and then click on the OS disk. Uncheck everything here except ephemeral, and then just select the disk that you want. Now tell us how many hosts you want to do at a time, and if we run into any kind of trouble, how many issues should happen before we just stop the whole process. And optionally, you can set it so that after your first group finishes successfully, just put all the other hosts into drain mode, which means that everyone will be forced to reconnect to ephemeral hosts. And you can also force users out if you need to. Then click Run Now. And if you want to have an ephemeral pool right from the beginning, just go to build a new one, and then for your VM size, select a supported size for ephemeral disk, and then select the disk type. And now, if there's a downside to ephemeral hosts, and I'm not saying that there is, it would be that you really need to think differently. Remember, ephemeral hosts can never be shut down. They can only be created or destroyed. So is the rest of your provisioning processes able to support that? Is everything just inside your image? Or are you supporting your image with scripted actions and other app deployments? If you've got most of that stuff all automated, then you're in a great position to use ephemeral disk. But you're not done yet, because ephemeral disks really shine with autoscale, because you not only automate the whole process end to end, you also optimize it with all the extra controls that autoscale offers. Just click the 3 dots, go to autoscale and configure, then scroll down to the VM templates. Just pick your supported size and then select your ephemeral disk. But wait, there's more. Scroll down some more and you'll find the cost estimates. And there is your storage costs. Now go down to the host pool sizing section. And this is where you have your base, min, and burst capacity numbers. Set the base and min to 0, and then your burst to 10. Then scroll back up to your estimates, and now that is some nice savings. And when you like the way the numbers look, click Save. And now that you've fixed the 4 things that you keep getting wrong, you should really learn about the other things that autoscale can do for you right here.